In this video lecture, we will understand about rate of reaction and order of reaction. Now let's understand the meaning of rate of reaction. Rate of reaction may be defined as change in concentration of reactant or product per unit time during a reaction. For example, we have a reaction in which initial concentration of reactant is 4 molar and that of product is 0 molar. So we can say with the passage of the time, the concentration of reactant decreases and that of product increases. So we can say change in concentration of reactant or product per unit time is called as rate of reaction. Mathematically, it can be represented as rate of reaction is equal to delta. Delta means change in bracket reactant or product concentration. These bracket indicates molar concentration or molarity divided by change in time. So we can say rate of reaction is change in concentration of reactant or product per unit time. As we can see, rate of reaction can be explained in terms of reactant as well as in terms of product. The concentration of reactant decreases with the passage of the time, so we can say rate of reaction may be defined as decrease in concentration of reactant per unit time. Or in terms of product, we can see the concentration of product increases with the passage of the time. So we can say increase in concentration of product per unit time. So we have following 3 definitions of rate of reaction. Number 1, change in concentration of either reactant or product per unit time. Number 2, decrease in concentration of reactant per unit time. Or number 3, increase in concentration of product per unit time. So let's have a reaction. A gives you B. So its rate expression can be written as rate of reaction minus delta A divided by delta T. Minus sign has no mathematical significance. It simply represents that concentration of A decreases with passage of the time. So always remember, whenever you write the expression in terms of reactant, then you should put negative sign before the concentration of reactant. In terms of product, that is in terms of B, we can write the expression rate of reaction is equal to delta B divided by delta T. Since the concentration of product increases with the passage of the time, so that is why right hand side expression possesses positive charge, positive sign. So remember, for reactant negative sign, for product positive sign. Units of rate of reaction: for liquid medium reaction, mole per liter per time. For gaseous medium reaction, atmosphere per minute or atmosphere per second or atmosphere per time. Now let's understand the relation between rate for reaction taking place in gaseous and solution medium. Now let's consider a reaction taking place in liquid medium. So its expression can be written in terms of concentration. For A, decrease in concentration of A per unit time, and for B, increase in concentration of B per unit time. But if the same reaction takes place in gaseous medium, so expression can be written as in terms of partial pressure, because concentration of gases is measured in terms of partial pressure. So decrease in partial pressure of A per unit time or increase in partial pressure of B per unit time. So in this manner we can calculate rate of reaction in terms of liquid medium and in terms of gaseous medium. So rate in atmosphere second inverse means rate of reaction in gaseous medium is equal to rate in molarity second inverse means rate in liquid medium into RT. So rate of reaction in gaseous medium is equal to rate of reaction in liquid medium into RT. R is the universal gas constant and T is temperature in Kelvin scale. Units of R 0.0821 if pressure is in atmosphere. Types of rate of reaction. Rate of reaction is of two types: instantaneous rate and average rate. Instantaneous rate means rate of reaction at a particular time, and average rate means the average of various instantaneous rate of reaction. So the question arises, which should be preferred, instantaneous rate or average rate? So the answer is we always prefer instantaneous rate because it gives actual rate of reaction. Write the mathematical representation of average rate and instantaneous rate. So average rate is written in terms of delta concentration divided by delta time, whereas instantaneous rate is written in terms of D concentration divided by D time. So if we have letter D, it means small change in concentration, which represent instantaneous rate, and delta represent average rate of reaction. So expression for rate of reaction: change in concentration of either reactant or product divided by coefficient as represented by balanced chemical equation and divided by change in time. For rate of appearance and formation, now rate of formation is different than that of rate of reaction. For rate of appearance or formation, the expression is change in concentration divided by change in time excluding coefficient. Similarly, for rate of decomposition or disappearance, we avoid coefficient and we only use change in concentration divided by change in time. So, what is the relation between rate of reaction and rate of appearance or disappearance? So students, you can use direct formula. Rate of appearance or rate of disappearance is equal to coefficient into rate of reaction. So if we know the rate of reaction, we can find out rate of appearance or disappearance. Order of reaction. Order of reaction is the sum of concentration terms on which rate of reaction actually depends. Order of reaction can be found out only by rate law expression. So we can say sum of the powers present in rate law expression is called as order of reaction. For example, if this is the rate law expression, hence the powers are A and B, so the order of reaction is A plus B. So sum of the powers present in rate law expression represent order of reaction. Order of reaction can be determined experimentally and not theoretically. It can be determined only by rate law and not by law of mass action. Types of order of reaction. Zero order reaction. These are those reactions which does not depend upon any concentration terms. In rate law expression, the power are zero. It means the rate of such reaction does not depend upon concentration. All the photochemical reactions are zero order reactions. First order reaction. They directly proportional to concentration terms. So let for the reaction, the rate law is, since the powers in rate law expression is 1, so it is first order reaction. Always remember, all the nuclear reactions are first order reactions. Second order reactions, these are those reactions which depends upon two concentration terms, as we can see by the reaction and the rate law expression. Third order reaction depends upon three concentration terms, as we can see by the reaction. Second order and third order reaction are least important from examination point of view. Otherwise, from experimental point of view, they are most common reactions. Fourth order reaction is the reaction which depends upon four concentration terms. Fractional order reactions possess fraction as the order, as we are seeing. The order of reaction is 1.5. And the last is negative order reaction. These are those reactions whose rate decreases with increase in concentration of reactants. Means rate of reaction is inversely proportional to concentration. For example, if in this reaction we increase the concentration of OH ion, rate decreases, so it is negative order with respect to OH ion concentration. Similarly, the example of decomposition of ozone, if we add O2 to the reaction mixture, the rate of reaction decreases, so it is negative order with respect to O2 concentration. So in short, we can say all the reversible reactions are negative order with respect to products concentration and positive order with respect to reactants concentration. Negative catalyst also result in negative order.